Finally, we turn to the solution of exercise 5, where you were asked to give probabilities. Here's the first figure. You are asked to give probability PE1 that brings indifference here. And again, we're going to analyze assuming expected utility. We have indifference, so these two prospects must have the same expected utility. We're going to write the equality, but we're going to make life very easy by using a normalization of utility. We're going to set, we can always do it, We set utility alpha 0 equals 0, utility alpha 4 equal to 1. That means utility alpha j is j over 4 for all j. It doesn't matter if we use other utilities, we have a bit more difficult algebra, but we get the same probabilities, of course, the same results. Anyway, with these values, we can say the expected utility of the left prospect is just utility of alpha 1. The expected utility of the right prospect is PE1 utility of alpha 4, etc. And we can substitute some values. We know that utility of alpha 1 is 1 over 4. We know utility of alpha 4 is 1. Utility of alpha 0 is 0. We substitute it here, and we find the expected utility of the right prospect is just that probability PE1. So we find the utility of alpha 1/4 is PE1. In fact, you saw those such mathematics already with the standard Campbell method. So this is the same mathematics. The second figure, the same. You can guess how it goes. Again, expected utility. We write the equation. Utility of alpha 2 is now that expected utility here. Utility of alpha 2 we know is half. So half is PE2. The third figure, same kind of algebra. We get PE3 must be 3 over 4. So expected utility predicts that your probabilities were 1 over 4, 2 over 4, 3 over 4. Again, empirically, what do we find? Empirically, well, we find quite some violation. We find systematic violations again. Usually the probabilities are higher than what expected utility predicts. That's, again, one more violation, one more reason to find new theories. This problem and the problem about the gammas is something that prospect theory will fix. The deltas, well, let's not talk about that, a bit depressing. Now I put here the common findings. So here, many experiments were done, and this is the common findings that people have with it. Many of these measurements were identical measurements to the alphas according to expected utility, and these equalities can be tested. I already told you the betas. This is a quite sophisticated test of expected utility, but it is commonly found that the betas do not systematically deviate from the alphas. So that prediction of expected utility is usually not violated. With the gammas, we do find violations. Empirically, we find that the gammas are usually smaller than the alphas. So that's a violation of expected utility. And the deltas, maybe it's good to know that there's some accumulation going on in deltas. If delta 3 is too big, for instance, that will make delta 2 extra big. If all these deltas have a little bias upwards, it will accumulate. Every new delta will have extra bias upwards in addition to the ones before. That's why you can explain the strongest violation to happen with delta 0 and less so with the other ones. And that's the empirical finding. Usually delta 0 is much bigger than alpha 0. There's indeed a bias going upwards, and the others may be less strongly so. Finally, probabilities I already told you. I just told you that we also find significant violations. They're usually bigger. Although with PE1, it's less strong. There's some optimism for small probability, but let's not get into details. But anyway, we find quite some deviation from expected utility. This adds to our motivation that we want to develop behavioral theories, this little experiment that we could do ourselves. And we know already it can't be perfect because of the deltas, but let's not talk too much about the deltas. So behavioral theories are to come, and those things will happen in next recordings.